Hi everyone, today we are going over the Chapter 2 lecture for graphic art, and this is going to be split into two parts. We're going to do the elements of art and then the principles of graphic design separately because it's a lot of information to cover and it is in your book. So to get started, Chapter 2 is the art of graphic design, and that is all about composition and the design or arrangement of parts on any two-dimensional surface, and that's a quick little visual of some different compositions. Now the elements of art are line, shape, color, value, form, and space. And there are some visuals here for you to kind of think about those, but we're about to go in depth on all of them. So starting with line, which is a path on a two-dimensional plane. A lot of elementary art teachers like to describe a line as a dot that takes a walk because it's from one point to the other. And there's lots of types of lines, vertical, horizontal, diagonal, curvy, spiral, wavy. I could go on and on and on. You can have lines of all types, and it's the best way to represent images, which is kind of funny because we don't actually see outlines when we look at real things. I'm just looking around the room right now, and there are no dark outlines of anything, but when we see a drawing, like a contour line drawing, we recognize those images instantly. Now moving on to shape, which is when multiple lines' ends meet or overlap to enclose a space. And that's kind of a wordy definition or a way to describe shapes. Another way to define them is geometric and organic shapes. Geometric shapes are those shapes with names that we might know, like squares, circles, triangles, rectangles, etc., usually with regular edges, straight lines, not as typically found in nature, whereas organic shapes are irregular and can be found in nature, and examples of those would be a leaf or a shell. Your textbook gives the example of a pond, which is usually some sort of oval shape that's in the right side of this image. You can kind of see some recognizable images, but organic shapes are usually found in nature. Geometric shapes can be found in nature. If you look at the crystals of a snowflake even, those are kind of geometric shapes. But typically, if you find it outdoors, a lot of those shapes are going to be organic because things in nature typically aren't perfect geometric shapes. And then forms are kind of shapes that grow up. They seem to have depth or volume. They have length or width. So those would be those three-dimensional forms or shapes. You can draw things to look three-dimensional, and that would be drawing a form versus, so if you're drawing a cube with three sides and depth and volume, that would be your form. But if you're just drawing a square, that's your shape. And now we're going to move on to space, which is the empty or open areas around or within a work of art. And that can be broken down further into negative and positive space. So the negative space is the space around the objects in a composition, and the positive space are those objects or elements in the composition. Here are two design elements or design examples that show the foreground and background, which is the relationship between the negative and positive spaces. In this key design, you see that the positive space here is this yellow key. But when it's placed on top of the black background, you see that the key creates a cityscape. So design can really be used to utilize the positive and negative space to get a message across, like the key to a city. This is the FedEx logo, which you've probably seen before, and within the EX of FedEx, you see an arrow, and that might not be initially obvious, but it was a specific design choice, and it makes sense. It's moving forward, moving things along. FedEx is a logistics company. It makes sense that they would want to incorporate an arrow, which kind of represents movement, into their logo. And now we're moving on to texture, which is the way a surface feels or appears to feel. And some examples of that are rough, smooth, hard, soft, etc. And your textbook actually listed shiny and dull in texture. And I would like to have a class debate about whether you think that should be in there in texture, because to me, you can't feel shiny. You can feel something that is smooth that could also be shiny, or maybe something that is slimy or wet could look shiny. But to me, shiny isn't a texture because it's not something you can feel. If you close your eyes and you feel a brand new car, you don't really know that it's shiny. But I am up for debate on this one. Implied texture is invented texture. For example, this drawing of this cute puppy, you can see that the artist has painstakingly drawn each little hair, and it looks so realistic and fuzzy. But if you touched that drawing, it would still feel like paper. Whereas actual texture is something that feels the way it looks. So the photograph of a puppy in real life would feel soft. And I Google imaged this, and I found this dog, and then I found a picture of a dog that kind of looked like it. I wanted to get that clear comparison of implied versus actual. Now we're moving on to color, which has lots of elements. So color is created by wavelengths, and the human eye sees the Roy G. Biv spectrum of colors, which is used to describe red, orange, yellow, green, blue, indigo, and violet, which you're probably familiar with. And this is a visual of how color is perceived in light. So white light is going into this glass prism and coming out as the full spectrum of light. And the spectrum is the range of color made up of refracted or bent wavelengths of light. And you've probably seen real-life examples of this if you ever have seen the sun shining through water droplets, or if you've seen a rainbow. That is a real-life representation of the full spectrum of light as light is refracted. Color continued. We are familiar with primary colors. If someone asked you what the primary colors are, you could probably say that they're red, yellow, and blue. That's what we learned from elementary school. And then secondary colors would be two primary colors mixed together. And then complementary colors are colors that are opposite from each other on the color wheel. And they're usually one primary color and one secondary color. This video does a pretty good job of explaining the color wheel in a little bit more advanced terms than maybe the color song you may have heard that says like red and yellow makes orange. So if you want to give this a look, the slides will also be on Canvas. It's a pretty short video, but it goes through color very well. But we are going to skip it for now. So additive primaries. These are not the red, yellow, blue primaries that we're used to. Additive primaries are the primary colors of light. So remember when we were talking about how white light refracted gives us the Roy G. Biv color scales. So if you think about it that way, the primary colors here are red, blue, and green. When mixed, they create white light. So it's kind of like if you were looking at that prism backwards and you took all the colors, sucked them back into the glass prism, and they result in white light. I didn't mention this before, but I will on the next slide. In our classic red, yellow, blue primaries, when you mix those colors together, you get black. So this is the traditional color which we use to mix paints. You're probably the most familiar with this kind of color wheel. White here is the absence of color, and complementary colors here would be red and green. That's our kind of traditional color wheel. Now, when we're talking about photocolor, or the color of light, we're mixing light. So that's what is happening in a camera or Photoshop. And black is the absence of light here. So when all the colors are mixed together, remember those additive complementary colors, when those red, green, and blue are mixed together, you get white light. So here complementary colors are red and cyan, actually. And then in a printer, it's another type of color. So we have CMYK, which is cyan, magenta, yellow, and black. Our color printer in the computer lab is named CYM. So now that kind of makes more sense, maybe. There is no white. The white is your paper. You can have black ink too, and then the CMY is what makes all of your other colors. And here, complementary colors are also cyan and red. And now we have properties of color. There's a lot that goes into color. We have hue, value, and intensity. Hue is the name of a color in its pure form and its position on the color spectrum. So the colors that you can name: yellow, orange, red, purple, blue, green, those are the hues. And then value is the degree of lightness or darkness of a color, which you might know from intro to art or if you've taken drawing. So value is always the lightness or darkness, and you can see that here on the right side of this visual. And then the intensity is the brightness or dullness of a saturation level. So you can kind of use saturation or intensity interchangeably. So here is the red fully saturated, and then when it's more dull or less saturated or the intensity is lower, you kind of fade into this gray color. So it's sometimes it's hard to keep these straight. I recommend going into Photoshop and kind of choosing a color swatch and then maybe adjusting the hue and saturation levels just to kind of see how those change. It'll help you get a better understanding of hue and saturation. And then simultaneous contrast is the changing perception of colors when they are placed next to each other. So in all of these pairs, the inner rectangle is the same color. So these two greens are the same, but because they're placed next to this pink and then this kind of darker maroon color, they have much different appearances. The green here looks a little bit lighter versus the green there looks darker. In each of these pairs, the middle rectangle is the same, but it looks different because of the color that it's next to. And this is something that fashion designers or interior designers really pay attention to because it can change the entire effect of a design or look. And then this video is pretty good. The yellow rectangle in the middle stays the same throughout the entire video while the background colors change. And you really will notice that the appearance of that yellow changes. Sometimes it looks brighter or duller. It's really interesting to think about how that can be achieved. So there are many ways to achieve contrast. I'm gonna keep moving past that video. And then we have color and vision continued with after image. The appearance of a primary color's complement when you close your eyes or move them to a white background. So I'm gonna pause here and we're gonna count to 10 while looking at this image. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And when I flip to that next page, what did you see? I could still see the word after image, but it looked kind of like that bright green or even almost a bright blue, but I could still read the word after image. If you need more time, you can always go back and pause at that past slide and take a minute there before going on to this white slide to see if you can get the difference. And if you Google these, there's a lot of different examples of them. It's a little bit of like when you don't look into the sun, but when you glance at the sun and then you look away and you can still see it in your eyes, it's a little bit like that. But this is a great time to take a break, so you can watch the other video later. But that is the end of the elements of art.